Hello everyone, today is our seventh lecture of the data science course, and today we are going to talk about introduction to neural networks. So, what is the key components of neural networks? So, we have inputs. So, the data or feature that are fed into the neural network, such as images, text, or sensor data, means the neural network consists of the images, the text, or sensor data, which are interconnected to each other. It also have hidden layers, the intermediate layers that extract and transform the input data into more complex representations which are hidden. So it is called as hidden layers. 30, what are the outputs of it? So the final predictions or classifications produced by the neural network, such as object labels or regression values, uh, these are the outputs which are given by the neural networks. So neural networks are used nowadays very widely. So it is a very important concept. Now we'll talk about the supervised and unsupervised learning. Firstly, we have the supervised learning. So the neural networks is trained on labeled data, learning to map inputs to desired outputs. So whenever we have the labeled data by which we learn maps, we draw maps into the desired outputs. So it is the supervised learning. We have the enforcement learning. The neural network learns by interacting into environment and receiving rewards or penalties. We have the unsupervised learning, which is the neural network discovers patterns into our structures in unlabeled data without explicit guidance. So we have this unsupervised learning where we have the patterns and structures. Now we have how we can implement neural networks in R or Python language. So firstly, by data preparation, first we'll do data preparation. We pre-process and format the input data to be compatible with the neural network architecture. Means first we will prepare the data, the formatting of the data. Means we'll prepare a blueprint of the data of the neural network. We'll give an architecture so we can write its code in the R or Python language. Second is the model definition. We specify the layers, activation functions, and hyperparameters of the neural network models. Means we'll build different functions, different block of codes, so that we have the uh, clear code in our language. Means we can write different blocks in R or Python, uh, different functions, which makes our network more compatible to use. Thirdly, we have the training and evaluation process in which we iteratively update the model's weight to minimize the loss and assess its performance. Means we'll update the model weight so we can have the less loss and we can improve the performance. Thirdly is the deployment of the model. So by integrating the trained neural network model into a production environment or application, we can deploy it. Now we'll talk about the practical applications of neural network models, means how it is used in daily lives, where places it is used, because I have told you earlier that it is widely used nowadays. So we'll see where it is used. So firstly, it is used in computer vision. So neural networks excel at tasks like image classification, object detection, and image segmentation. So it is widely used in computer vision. Secondly, it is widely used in natural language processing, like SMS. All you have SMSs in your mobile. So it is done with the help of neural networks. Nowadays, you use WhatsApp, Instagram, Facebook, you send messages there like Messenger, you use Messenger, uses various SMS apps. So it is implemented using neural networks. So neural networks can use for language translation, text generations and sentiment analysis. Like we have AI today. So you can see that language translation is a process of we see in AI. So this is because of the neural network. Thirdly, we use in robotics and controls. As I have earlier said, in AI we use it. So neural networks can help robots navigation, manipulate objects, and make decisions in complex environments. Thirdly, it is widely used in healthcare and bioinformatics also. Means it is a tough or means rigid part of healthcare and bioinformatics. It is used very widely in it means network is very widely used in healthcare and bioinformatics. Like neural networks are used for or disease diagnostics, discovery, and get analysis of the body of the person. Means if we have some disease or anybody have some disease, so for knowing them, for discovery of that, if someone has a new disease, like in pandemic we have corona, for discovering it, what type of virus it or what type of disease it, a neural network is widely used. What now we'll see the limitation and considerations of the uh, neural networks. We have interpretability. Neural networks can be black boxes, making it difficult to understand how they arrive at their predictions. So sometimes the prediction can be wrong also. So one is this is one of the limitations. Second, it data requirements of the neural network. Neural network often require large amount of labeled training data, which can be time consuming and expensive to acquire. Means it is expensive also, and it is a large, so we have to store it also. So for storing it we also have to expend some money. It has a large expenses on it. So and also the data amount of data is also big, so it is difficult to store it. Thirdly, it has computational resources, which is also a limitation of it. So training and running complex neural network can be computationally intensive, require powerful hardware and specialized software, which is one more of a cost, not cost efficient. Means will provide powerful hardwares like powerful GPUs, powerful CPUs for running it. So not everyone can run it, but the only the person who have this hardware and software can run it, which is not so cost efficient. Thank you for this lecture. For more topics, we'll talk about in next lecture. Thank you.